Welcome to Honors Physics, video number 2. Today we're actually going to talk about some physics. This is unscripted, so we'll just have some fun with this. Today's video is called Putting the Fit in Physics. We're going to talk about motion, distance, and reference points. Specifically, we're going to be talking about this thing that we call kinematics. And kinematics is a big study that we're going to do this year. And it's helpful to know a little bit about the origin of the word kinematics. So kinematics, when you think of it, has this prefix kine, K-I-N-E right here, kine. And kine, go ahead and think for just a minute about where you have seen similar sounding or similar looking words. So go ahead and think. I'm going to give you 10 seconds. Now, there are a number of them, but here's 3 that I thought of. First, I thought of the word kinetics, and you may have heard that in some sort of engineering or science-y other class. It deals with motion. Kinesiology is the science of understanding motion and the way that the human body moves, those types of interactions. And then one that you may not have thought of, but that actually goes right along with this, is cinema. Eventually we got rid of the kind of hard-sounding K in kine, and we ended up with this sound, and we have cinema. And so cinema really was what? It's moving pictures. So all of these then have to do with motion. If we look at these right here, these 3, the common term between them is this idea of motion. Moving objects, moving bodies, moving pictures, all of those pieces right there. And the word kinematics actually comes from this piece that we looked at called kinetics. And when we take a look at the origin of the word kinetics, here I am with my dictionary stuff again. It comes from the Greek, right? And it comes from moving, and it's equivalent of kine here, right? So we see that term kine again coming up here. And so when we talk about kinematics, what we're going to be talking about today is a number of different things. So we're going to be talking about this idea of position, where an object is. We're going to be talking about a reference point, which has to do with describing an object's position. A reference frame has to do with how an object's position looks or changes to us based on where we are. And then we have this idea of what we call distance, and then this idea of displacement. So these are the kind of 5 things that we're going to be talking about in this video here today. Should take, maybe about 10 minutes or so. So first we're going to talk about position, and when we talk about position, we look at a number line. So if we had a number line here and we had this kind of arbitrary 0 point here, that means that to the right we would describe those positions as 1, 2, 3, 4, and 5. And 1 represents 1 position to the right, 2 represents 2 positions to the right, 3 represents 3, and so on and so forth. And then the negative numbers here represent going to the left. So as is the case in all the time in physics, we are going to consider the right direction to be positive and the left direction to be negative. That's important for you to understand, because as we go forward, we're going to be talking about positive and negative positions. So if we took a look, relative to this 0 point, it's fairly easy to tell where we are. So if I were to place a red X on the number 4, we would say the position of the X is what? Well, that position is 4. And if we were to assign, say, some unit here like meters, then we would say that the position of the red X was 4 meters. Likewise, I could put a green circle over here, and you would, in theory, then realize that the position of the circle, and I can spell, I do promise. I can also erase sometimes. Position of the circle would be what? Well, we see that it is at the -5 position, so that means that we would say the position is -5 meters. Okay, and we can go through this and do a whole bunch more examples, but the idea is that we have this 0 point, this arbitrary 0 point that we just marked as 0, and we call this our origin, right? This is our origin. This is our original location. This is where we are saying a 0 position exists. So then if I were to put a blue, squiggly line, right, something like that, there, then the position of the blue squiggly line, that would be represented as 0. Now this part makes a lot of sense because we have this really good notion of position relative to something else, relative to an origin. You see all the time, we've got graphs, right? So when you mark a graph and we have some xy coordinate, say this is 2, 2, right? That's our xy position. So when we talk about position here, we're really just talking about the same thing that you see when you graph something. We are going to start this unit in 1 dimension, and then after the end of the first quarter, we're going to be moving into 2 dimensions. But the position is just, the location of something relative to what we call our origin. Now, it's slightly different than a reference point because a reference point doesn't have to be at 0. So if I wanted to make my reference point here at -3, okay, I put my reference point here at -3. What a reference point is it is a moving of the origin. Moving, or just simply the location of an origin. So we kind of look at this origin. Okay, we look at this as where are we starting? Where is our initial location? Where is our 0 location? And so if I said that this was my new reference point, now we have some different things. Now let's take a look. When we were back here under position, right, we had, and my red X somehow disappeared. So my red X was at 4 meters here, right? And then my green circle was at -5, my blue squiggly was at 0. So if I transfer those positions over here, here's my red X here, and my green circle's over here, and then my blue squiggly is right here. If I wanted to write those positions again, I would have different numbers. Now the red X position would be something, the blue squiggly position would be something, and the green circle would be something. See if you can take a look. The positions relative to this reference point, what are the positions of each of these? And I'm going to give you just a couple minutes to think about that. Well, not a couple minutes, about 10 seconds. What you should see is that this was a 4, or this was at 4, this is at 4. We moved our reference point to 3, so now the distance in between them, or the number of spaces between them, is 7. So according to this reference point, I now have 7 meters in between. Okay, the circle, the green circle, is now 2 to the left instead of being 5 to the left, so now this is -2 meters. And similarly here, I've got this distance here, and I'm running out of space for these. That's going to be now 3 meters. And so just by moving my reference point, I now have a completely different set of positions. And the position that we talk about will always be our position relative to our reference point. If no reference point is given, we will call the origin our reference point. For motion, what the reference point means is that I can be moving one direction or another based on where I am at. So if my reference point is here at 0, and I'm moving this way from the left, right, say I've got an X moving this way, and my reference point is right here, that means that I see this object moving toward me. But if that same object then moves over here, the object is now moving away from me. Similarly, if I move my reference point, or I guess conversely, if I move my reference point, say I move it to -2 now instead of -3, that transition point moves from where what it was at 0 to where it is now at -2, which means that any time over this way now the object is moving away from me. So we talk about reference points with motion to look at whether the object is moving toward or away from you. And in fact, we will even get into what happens when our reference point is moving. Say we started at 2 and moved to the left here. We're not going to get into that today, but we will at some point in time. Now, when we talk about this idea of distance, we talk about a total amount of positions that we have traversed through. So what that means is, say I started at 0, and I went up to 2, and then from 2 I went back down to 0. I first went up 2, and then I went down 2. But the question is, how many total positions did I traverse through? Well, I went from 0 to 1, 1 to 2, that's 2, and then I went from 2 to 1 and 1 to 0, so that means that my distance here was 4. So my distance is 4 meters. Okay, so, but then we talk about this idea of displacement, which the displacement is the difference in the starting and the finishing locations. So displacement is the difference in the starting and the finishing locations. So what that means is if I go from 0 to 2, and then I go back from 2 to 0, I did technically travel, as we saw back here, 4 meters, but here I traveled 4 meters of distance, but my displacement is the difference between the starting and the finishing location. So where did I start? I started here. Where did I stop? I also stopped here. Right, you see what there with the green and the red? So that means that my total displacement is 0 meters. Total displacement is then 0 meters. Okay, and this is an idea that we're going to spend a lot of time on. In fact, we're going to spend an entire video on it next time. This idea, this difference between distance and displacement. But for now, you can just remember this, that the distance is literally just the amount of positions we went through, and the displacement is the difference in the starting and finishing locations, or we can also call those positions, right? Because a location and position, for the purposes of this class, will be the exact same. Okay. Now, let's take a look, and let's see a couple of different possibilities for reference frame. Remember how I was talking about reference frame with motion. Now, if we were to watch this video right here, so to watch this, those two cars that started off at -5 and -2 respectively, they're traveling at the same speed. So relative to each other's reference points, the cars are motionless. Think about that. Relative to each other's reference frames, the cars are motionless. The car in the back, as it moves forward, sees the car in the front, always the same distance, always the same location, always the same speed. It travels like that. That's in contrast to a situation like this, where the car in the back is moving faster. Or like this, where the car in the front is moving faster. Okay, so we're not going to get a lot into this right now because this goes into speed and velocity, but I wanted to get your understanding about why the reference frame is important here, because we can see that there are 3 different scenarios. We've got these cars moving in tandem with each other, the back one overtaking the front one, and then the front one overtaking the back one again. Okay. So based on the stuff that you saw today, I have, I think, 6 quick quizzes for you to take a look at. And I'm just going to go quickly through these. What I would encourage you to do is to pause them as you're working on them, take as much time as you would like, and then restart once again. So here's quick quiz number 1. Mr. Packle's driving down I-66 when he remembers that he forgot his lunch. This is a true story. It happened last week. I got on the freeway at exit 70 and remembered my lunch at exit 60. Each exit represents 1 mile. How far is Mr. Packle from his starting point on the freeway? Okay, so go ahead and work on that. Go ahead and pause. Restart when you're ready. Okay, and you're back, and here is the correct answer. 10 miles, right, because how far I am, it talks about what is my position from my starting point. So I am at 60, I started at 70, so I am 10 away. Okay, same question, but the new question is, how many extra miles did I have to drive? How many extra miles did I have to drive? So restart when you're ready, but go ahead and pause. All right, and you're back, and we noticed that I was 10 miles away, so I went forward, or I had to go back to exit 70, and then I had to go back up to exit 60, so each of those paths was 10 miles, and if each path is 10 miles, then we see that the total distance is 20 miles. I'm driving down I-66 when I see a police officer driving in the same direction. I'm going the speed limit of 55 miles per hour, and the police officer is getting farther away from me. Who is going faster? Go ahead and pause and restart when you're ready. Welcome back, and if we're going in the same direction and the police officer is getting farther away from me, we see then that the police officer is going faster, as you saw back in the PowerPoint previous. Same question, but now the police officer is getting closer to me. Go ahead and answer that question. And welcome back. We see then that I am going faster. The police officer must be going less than 55 miles per hour there. Quick quiz number 5. I travel along the following route: east 5 meters, west 10 meters, east 17 meters, and west 17 meters. How far did I travel in total? Go ahead and figure this out and pause. And welcome back. You should have seen I'm looking at how far did I travel total, not where did I end up compared to where I started. So you're simply adding these together. 5 plus 10 plus 17 plus 17 gets us 49. And final question is the same route, but how far am I from my initial location? Go ahead and pause and restart when you're ready. And welcome back. We're looking at how far I am from my initial location. So if I go east 5 meters and west 10 meters, that means I erased 5 meters of this, and I'm 5 meters west of where I started right now. Then I go east 17 and west 17. These two kind of cancel out, right? This is like plus 17, minus 17. So in the end, I am simply 5 meters from my initial location. That's it for today. Next time we're going to cover 2 topics, this idea of the difference between distance and displacement, which I call distance and displacement third cousins twice removed. And then we're also going to be covering speed and velocity, which are 2 terms that you may have heard kind of interchangeably in the past, which are not quite so interchangeable. Thanks for tuning in. See you next time.